Most people think that trigonometry only applies to triangles, but it actually has some important uses in calculus and the behaviour of waves, particularly sound waves. The trigonometric functions sine, cosine and tangent all have their own distinct graphs, and we're going to look at each one separately. It's important to note that the x-axis for trigonometric graphs represents degrees.
The graph of y equals sine x is the best place to start. The graph starts at the origin, rising to its maximum, which is 1 at 90 degrees. It then falls back to 0 after 180 degrees, down to its minimum of -1 at 270 degrees, and finally back to 0 at 360 degrees. After this point, the graph repeats itself, so we can say that y equals sine x has a period of 360 degrees. This means that the graph repeats itself every 360 degrees. By plotting these 4 simple points, you should be able to draw this graph yourself. Just remember the wave shape that the graph has.
The graph of y equals cosine x has a very similar shape to sine x and has some important points to remember also. The graph starts at its maximum value of 1 at 0 degrees. It then falls to 0 at 90 degrees, continuing to its minimum of -1 at 180 degrees. It then rises back up to 0 at 270 degrees before reaching its maximum of 1 again after 360 degrees. Like the sine graph, this means that y equals cosine x has a period of 360 degrees.
The graph of y equals tan x is very different to the other trigonometric functions. Unlike the other graphs, this graph is not one continuous wave. Instead, the graph repeats itself every 180 degrees, but one part does not join on to the next part. Also, unlike the other graphs, the tan graph does not have a maximum or minimum. Instead, it continues on to infinity and negative infinity.
The reason that the graph does not connect is because there are invisible lines called asymptotes that the graph can never touch but does get very close to. These asymptotes repeat every 180 degrees, meaning each separate graph only has a period of 180 degrees. If we take the first part that passes through the origin, it has asymptotes at -90 degrees and +90 degrees. So it extends downwards to -infinity as it approaches -90 degrees, passes through the origin, and then extends upwards to infinity as it approaches 90 degrees.
We can also find solutions of each of the graphs. For example, if we wanted to find the solutions of sine x equals 0.5, we simply draw the graph of y equals sine x and draw a horizontal line from y equals 0.5, since this is the part that has been replaced in the equation. Our solutions are where the graph crosses the line. Do bear in mind that these will be approximate solutions, because as carefully as you might draw it, your graph will not be perfect.
Doing this gives us approximate solutions of 30 degrees and 150 degrees. This same method works for graphs of cosine and tangent too. Like all other graphs, trigonometric graphs can be transformed, but this affects the amplitude. This is the distance of a wave's maximum disturbance from its undisturbed position. It also affects the period, which is the length of one cycle of the graph. For example, let's look at how we transform the graph of y equals sine x. If we multiply the x part of the equation by a number greater than 1, say 2, what do you notice? Well, notice how instead of just one cycle occurring, in 360 degrees, there are now 2 cycles in the same interval. This means that the period of the graph has been halved, because it now repeats every 180 degrees. This also means that the 4 key points we mentioned earlier have their x-coordinate halved too, So the maximum moves from the coordinate point 91 to 45, 1. If we drew the graph of y equals sine 3x, then the period would be divided by 3, making it 120 degrees, and the x-coordinates of the intersections with the x-axis would be divided by 3.
Now, if we multiply the graph of y equals sine x by 2, giving y equals 2 sine x, what do you notice? The maximum value has risen from 1 to 2, and the minimum has decreased from -1 to -2. However, the x-coordinates of the intersections with the x-axis have not been affected. Basically, the y-coordinates throughout the graph have been doubled, meaning the amplitude has also doubled.